Welcome back. We're up to set 2, lines in the number plane, where we're going to plot some points on a set of axes. So the things that we need to remember is our x-axis is our horizontal axis, and this will always be our point of reference. Our y-axis is always our vertical axis, and using both of these sets of axes we'll be able to plot some points on the graph. We always start at the origin, which is this point in the middle, and using our x coordinate first and then our y. So if we work right or left, so if it's a positive value for x or a negative value for x, we move accordingly. And then we move up if it's a positive y value, or down if it's a negative value. We're going to move on to actually plotting some points. So if you have your book there under set 2 with your teacher, make sure you've turned to this point. So the first thing that you need to do is actually give the coordinates of points A, B and C. So the points are plotted for you on the graph. You can see A is there, B is there and C is there. So going back to our rules, starting at the origin, we're going to look at A first. We're going to go along our x-axis to position 8, and then we do our y coordinate, which is up, positive 2. Okay, so we write that in brackets 8, 2. So we always do our x coordinate before our y coordinate. Let's find B. So B is here, so if we start at the origin, we're going to go left to get closer to it, to -1, and then down to -3. So the point would be written as -1, -3. Make sure you bring your signs with you. If we have a look at C, it's here, starting at the origin, we go across to position 5 and down to position -7. Making sure that we put them in brackets. So that's one way you could be asked a question, just plotting points on the graph. The second way is to actually be given the points and then actually put the letters D, E and F on the graph. So let's look at D. We've got to put position at -3, 6. So if we go to the origin, so we always go left for a negative, down to here, and then up to position 6. So you could either write the letter D or the coordinates -3, 6. We're going to put an E now at position 8, -1. So again, starting at the origin, being an x term, we go across to 8, and then -1 is a down. So we've got E at this position here. And our last example is F at position -5 down to -1. So we put an F there. So I want you to have a go at set 2, page 35, question 1. Make sure you stop the video every time to do the examples, and then you can restart it. The next thing that we're going to do is plot these points to make a straight line graph. And the way that we do this is we substitute values for x into our equation. So every straight line will have an equation in this form, y equals 2x plus 1, and we'll learn a little bit more about that later on. So at the moment we're going to just substitute some values for x, find the y position, plot the points, and then if we've done it correctly, we'll find some points that line up in a straight line, rule through them, and that will be the equation for this example. So I'm going to substitute 0 every time I see x. So 2 times 0 plus 1. So that equals 1. And so our point is 0, 1. This time I'm going to substitute number 1. 2 times 1 plus 1 is equal to 3. Then I'm substituting number 2 in. 2 times 2 plus 1 makes 5. And then I'm going to substitute in number 3, makes 7. So when you've got your points, these are all neatly in the right sort of scale for us, but you need to look along your x-axis. We'll go from 0 to 3, and so you need to label your scale along the x side, making sure that every time you do it, it's consistent. So this is worth 1 unit from here to here and here to here, and that must remain consistent the whole way along, so you can't change it halfway through. On our y-axis, we've got from 1 to 7. So if it's a little bit tight there, you can just put in every second one, or every one if you've got the space. So let's plot the points. 0, 1. So we're at 0, doing our x first, and then at position 1. Then we go across to 1, position 3. 2, position 5, and 3, position 7. And if you've done it correctly, excuse me, you'll notice that all the line will join up with points. So what I'm going to do, and you would do, is use a ruler to join these points together and form a straight line. So don't do those freehand, please. So this is the equation of the line for a straight line. Okay, and you could write, if you've got the space, the equation for that particular line. Y equals 2x plus 1. And so some of you may know this already. The 2 refers to, in the straight line, the gradient, and it means that if we go across 1 unit, we're going up 2. Across 1 unit, up 2. And the positive 1 refers to where it crosses our y-axis, our y-intercept here, at positive 1. Let's have another example. This time we're going to have a look at equation y equals negative 2x plus 3. And so this is going to be an example of a negative slope. In the other example, you could see as you move from left to right, so if you go from left to right here, it slopes up, okay? Or if we draw a line here, it slopes up. Whereas a negative slope, as you go from left to right, slopes down. So we're going to do the same thing. We're going to substitute all our values in. You'll notice that you're going to have the same pattern. It's going to be negative 2 times your value for x here, plus 3 each time. So you may wish to set your working out and do the same pattern each time. So instead of substituting here negative 2, the next time it's going to be negative 1. If you can see that, then feel free to do all the working out in one go like I'm doing it. And then your y value will be the answer. Negative times a negative makes a positive. 2 times 2 is 4, and 4 plus 3 makes 7. So our coordinate is -2, 7. The next one, -2 times -1 makes 2. 2 plus 3 makes 5. And then the coordinate point is such. Can you predict what the next number will be? If you've done this before, it's -2. So what that means is the gradient is decreasing by 2 each time. So would look something like that. So minus 2 times 3 is minus 6. Minus 6 plus 3 is minus 3. So you can see that the pattern is consistent. And then just writing your points out. So to draw a straight line, you need at least 3 points. You need more than 2 points because you may have made an error in your equation. So you need at least 3 points on your graph to show that they line up to form a straight line. So let's plot these. So make sure that you label. So each of these is going to be worth, each of these lines is going to be worth 1 unit. So you would line up and draw your graph something like this. So let's plot these points. Minus 2, 7. Minus 1, 5. 0, 3. 1, 1. You can see that they are lining up 2, 1 and 3, minus 3. Okay, then using your ruler, you would insert, well, I'm going to insert, you're going to use your ruler to draw the straight line like that. Okay, and then like the last one, y equals minus 2x plus 3. So you can see as you go from left to right, it slopes down. It's got a negative rise. Okay, and so we can see that every time we go across one, we go down 2. Across 1 unit, a run of 1, a rise of negative 2. And you can see that it crosses here at the y-intercept of plus 3. So have a go at page 35, question 2, and pause for now. The next thing that we're going to look at is the gradient of a line in the number plane. So you may have used one or both of these formulas in the past. Okay, so remember the gradient is a measure of how steeply a line is sloping. And we can use the formula gradient equals rise over run, or gradient equals y2 minus y1 divided by x2 minus x1. So we're going to go through both of these examples in the next instance. So for both of these, or for all of these, we're going to use our rise over run method. Okay, so in the past you may have used the symbol M for gradient. We're going to use the symbol A for gradient from now on. So rise over run. Okay, so how do we work out what our rise is? Our rise is our vertical distance. So the way that you work that out is draw a small triangle. So in these examples, you have got 2 points already been identified. You can see they're on a sort of like a whole number at the edge. Okay, you could pick anywhere along here to pick 2 points, but you don't know exactly what they are. So make sure if you get the option that you pick a point that is clearly at a whole number. It makes it a whole lot easier. Okay, so your rise is your vertical distance in this triangle. This is your rise. And your run is the horizontal distance. So your rise, if you have a positive slope, and you can tell if this is a positive slope, is as you go from left to right, it rises up. Okay, you have a positive rise. Okay, your run will always be positive in the formula. We'll have a look at the example of the negative one in a minute. Okay, so let's count it out. 2, 4, 6, a rise of 6, and a run of 3. So it's just a matter of putting that into the equation. 6 divided by 3 gives you a gradient of 2, and that is your answer.